In this next section, we're going to take a look at what happens graphically at the x-intercepts, or in other words, the roots of a polynomial. So let's look at the graph of this polynomial. F of x is equal to x plus 3 times x minus 2 squared times x plus 1 cubed. So first let's take a look at the roots of this polynomial. So one root, if we took a look at the factor x plus 3 is equal to 0, one root is x is equal to negative 3, which we can see here on the graph. And notice that the graph passes through the point x is equal to negative 3. Let's take a look at this next root here. If we do x minus 2 is equal to 0, that gives us a root at x equals 2, but look at how the graph is different at x equals 2 than at x is equal to negative 3. At x is equal to 2, the graph touches the x-axis at 2, but then changes direction and goes back up. At x equals negative 3, it crosses, but at x equals positive 2, it bounces back up. And notice that the power here is an even power. Finally, let's take a look at the last root. If we take a look at the last root, x plus 1 is equal to 0 would give us the root x is equal to negative 1, and notice at negative 1 something completely different happens. At x is equal to negative 1, it crosses the axis, but not in the same way it did at x is equal to negative 3. Instead, it flattens out a little bit and then continues and crosses the axis. And notice that the multiplicity, the power on that root, is an odd number. So the effect of the graph it depends on the multiplicity of the root. If you have a single power, just for example x plus 3, the line will cross the x-axis. If you have a root with an even multiplicity, so for example x plus 2 is equal x minus 2 squared. If you have an even multiplicity, the graph bounces. In other words, it doesn't cross the axis, but it changes directions. And finally, if you have an odd multiplicity, so for example, the x plus 1 cubed, with an odd multiplicity, let's put that over here in the corner, with an odd multiplicity, the graph flattens out while crossing the x-axis. Okay, we're going to take a look at some more examples of that. Oh, so here's where we could write those notes in a more neat way. All right. So if the graph crosses the x-axis, then you have just one root there. In other words, multiplicity 1. If the graph touches the x-axis and bounces off without crossing, it's a 0 of even multiplicity. If the graph flattens out before or after the 0 crossing the axis, it's a 0 of odd multiplicity. And we saw all of this in the last example. And the sum of the multiplicities is always n, which is the leading term power. Okay, we'll do some more examples. Use the graph to discuss the zeros and their possible multiplicities of this polynomial. The degree of the polynomial is 6. Okay, so let's take a look at this first root. So we have a root at x is equal to negative 3. So x is equal to -3. Notice the graph bounces there. The graph doesn't cross the axis. So this has an even multiplicity. So x plus 3 is going to be a factor, and it's going to have a power here that's going to be an even number. Now let's see, does it bounce anywhere else? No, it doesn't bounce anywhere else. Let's take a look at the next root that we come across. The next root we come across is right here at -1. At -1, it simply crosses the axis. So x plus 1 is going to be a factor, and it's just going to be a single factor, multiplicity 1, because it just simply crosses the axis there. And finally, let's look at the third root. So it has a third root right here. So it has a root at x is equal to 4. In other words, x minus 4 is going to be a factor. Now see how it flattens out there before it crosses the axis? So it's going to have a power here, and this power is going to be an odd multiplicity. Now let's see if we can create the polynomial. We know that the degree of the polynomial is 6. So x to the 6th is the highest power that we're going to see in the polynomial. And let's see what we have so far. We have x plus 1 as one of the factors, only to the first power. We have x plus 3 as another factor, and this is going to be an even number. And we have x plus 1, x minus 4 as a third factor, and it's going to have a power which is an odd power. So let's just start putting in even and odd numbers and see what happens. So our first even number is 2, and the next even number after 1 is 3. What if we had a polynomial that looked like this? Well, that would have degree 6. And so now we've recreated that polynomial. Here, why don't you try this one? Which zeros, if any, have multiplicities that are even? So let me highlight the zeros for you. There's a 0 at 5, a 0 at 1, and a 0 at 3. So which of those, if any, have multiplicities that are even? The next thing we'll take a look at is a related topic called turning points. So turning points are points at which the polynomial changes direction. And a polynomial of degree n can have at most n minus 1 turning points. So for example, this graph has a turning point here because it went from decreasing to increasing, a turning point here because it went from increasing to decreasing, a turning point here. Now, at 4, you might say, well, what's happening at 4? 4 is not a turning point because the polynomial didn't turn around and start doing something else. It was increasing, it stopped for a moment, and then it kept on increasing. So it was not a turning point. Why don't you count the number of turning points this polynomial has? Remember, what you're looking for is an exact change in direction. Okay, so if you're wondering why that answer was what it was, let's show the turning points. There's a turning point here. It went from increasing to decreasing. A turning point here, from decreasing to increasing. A turning point here, and a turning point here. So that polynomial had 4 turning points.